Hello class, today we'll be learning about ratios. Now you've probably already learned about ratios in primary school, but today we'll be doing something different with ratios. Our learning objectives today are to simplify ratios and to find the ratio of three quantities. Now let's review what a ratio is. A ratio is when we express it as A to B, it's denoted by A to B with a colon, and that can also be represented by A over B. Now because we have a fraction here, B cannot equal to 0, because if we divide a number by 0, then we have an undefined number. Okay. Now you may have learned ratios where A and B are integers, but today we'll practice simplifying ratios where A and B are not integers. Okay. They can simply be any rational number. Okay, let's look at some examples. Okay, let's do some practice questions. Okay, now we can simplify the following. Now, what do we mean by simplifying a ratio? It means changing A and B so that they are both integers. Okay, so here we have 2 over 5 to 2, 1 and 2 over 3 to 3, 3 and 1 over 6, and 0.48 to 1.54. Now, I'd like you to take a few minutes and pause the video and try these questions on your own. Okay, now let's look at A here. We have 2 over 5 to 2. Now, we want both numbers to be integers. Now, here we only have one fraction. The number to the left, A, is 2 over 5. So, we need to multiply it by its denominator in order to get a whole number. So the denominator, of course, is 5. We're going to multiply both sides by 5. Okay, because when you multiply one side by a number, you have to multiply the other side when it's a ratio. So when we multiply 2 over 5 times 5, we get 2. We simply just cross out the denominator. Okay, 2 times 5, of course, is 10. So we have 2 to 10 as the simplified ratio. Now, what if we have 1 and 2 over 3 to 3 and 1 over 6? Okay. Now, we need to multiply both sides by the lowest common multiple for the denominator. Okay, that, of course, it would be 6. Okay, so we multiply 1 over 2, 3, 1 and 2 over 3 times 6, okay? And 3 and 1 over 6 times 6. Okay, so that should give us, we might want to, in this case, rewrite these as improper fractions. So we have 5 over 3 times 6, and 19 over 6 times 6. Okay, so that should give us, if we multiply both numbers by 6, okay, this should give us 5 times 6 is 30, divided by 3, of course, is 10. Okay, and here, the number that we're multiplying by is the same as its denominator. So we can just write the answer as the numerator, 19. So the simplified ratio is 10 to 19. Okay. Okay, what about C here? Okay, here we have two rational numbers written in decimal form instead of mixed numbers. Now, an easy way to do it, it might take a bit longer, but it makes things a bit easier, is to multiply both sides by a number so that there are no more decimals. Now, we see there are 2 decimal places in each number, so we can multiply both numbers by 100. Okay, so 0.48 times 100 and 1.54 times 100. Okay, and this, of course, gives us 48 to 154. Now, we could probably simplify this ratio even further. We know that both of these numbers are divisible by a certain common factor. Okay. Now we probably want to find the greatest common factor here. Let's see. What if we divided both numbers by 2? That'll give us 24, and I believe we'll have 77 here. Okay. I believe 77 and 24 do not share any other common factors, so this can be written as 24 to 77. Okay. All right, let's try another example. Okay, let's do a word problem here. Okay, a lemonade recipe requires 1.1 liters of water and 500 milliliters of lemon juice. Find the ratio of lemon juice to water. Okay, now how do we do that? First, you need to note, okay, you must use common units. Okay, so this is what you need to keep in mind. Use common units. Okay, here we have liters and here we have milliliters. So they must be rewritten so that they use common units. Okay. Secondly, find the ratio of lemon juice to water. Make sure you get the order correct. Okay. Lemon juice is written secondly here, whereas we have water written first. So let's start off with 500 to 1.1 liters would of course be 1,100 milliliters. Okay. Now, of course, this can be simplified. We do know that there are 2 zeros here, so they share a common factor of 100. We can divide both numbers by 100, and that'll give us 5 to 11. Okay, and that's the ratio of lemon juice to water. All right, let's try doing something with that particular ratio. We'll try applying it to a different problem. Okay, if 750 milliliters of lemon juice is used instead, how much water is needed? Okay, so remember our ratio of lemon juice to water is 5 to 11. Okay, now there are 2 methods of solving this problem. Okay. Now, we know the ratio can be rewritten as 5 over 11. Okay, this is method 1. Okay, and we know that 750 milliliters of lemon juice is used. Okay, so we can have 750 over the amount of water. Okay, now we could rewrite that as, let's say, let's keep it simple, use a variable, let's use x. Okay, 5 over 11 is the same as 750 over x. Now we can rearrange the numbers, cross multiply both sides by x and 11. That gives us 5x equals 750 times 11, which I believe is 7,500 plus 750. Okay, that should be 8,250. Okay. Now then we divide both sides by 5, and we get, okay, then we get x equals 1,650 milliliters. So, right, okay, 1,650 milliliters of water will be required. All right, our second method is to find the ratio of the 2 numbers by letting each number in the ratio be represented by x, okay, and the number of the ratio being the coefficient of x. Okay? So we can have 11x and 5x be the volume of water and lemon juice respectively. Okay? We find what x is first with the lemon juice. Okay? So 5x equals 750. That makes x equal to 150, I believe, if my math is correct. Okay? And then what we do is we find the volume of water by letting 11x, okay, by finding what 11x is when x equals 150. Okay, so 11x equals 11 times 150, and that will give us 1,650 milliliters. Okay, so we see using this method gives us the same answer as this method right here. Okay, so there are two ways of doing it: rewriting the ratio as a fraction and using x to substitute the quantity that you're trying to find, okay, or rewriting it as an algebraic equation with the number as the coefficient of x. Okay, you solve for x and then you substitute that into the other value that you're trying to find. Okay, in this case, 11x, which represents the volume of water. Okay, let's try our last example. This one involves finding the ratio of three numbers, okay, three values. Now, here you're given two ratios, and you need to change that into a ratio of three numbers. Okay, so the ratio of the annual income of Mr. Tan to that of Mr. Fong is 5:2. The ratio of Mr. Peck's income to Mr. Tan is 5:4. Find the ratio of the annual incomes of Mr. Fong to that of Mr. Tan and to that of Mr. Peck. Now, what you do here is you are supposed to find the lowest common multiple of the number in both ratios. Okay? Now, I've rewritten it this way. I've compared Mr. Tan's to Mr. Fong's income, here, 5:2, and I've rewritten this one right here, okay, to Mr. Tan's income to Mr. Peck's. Okay? Now, what you need to do is we need to find a common number for Mr. Tan's income for both ratios. So what you have to do is you find the lowest common multiple. Now, what we can do here is we can multiply these two numbers by 4 and these two numbers by 5. Now, why is that? Because the lowest common multiple of 5 and 4 is 20. So we need to multiply this by 4, both numbers by 4, actually, and these two numbers by 5. So when we multiply these two numbers by 4, we get 20 to 8. When we multiply these two numbers by 5, you get 20 to 25. Okay, so our final three-number ratio, comparing Mr. Fong's income to that of Mr. Tan's and to that of Mr. Peck, would be 8, 20, 25. Okay, that means if we were to say compare Mr. Peck's income to Mr. Fong's, it would be 25 to 8. Okay. All right, so that's it for today's lesson. Okay, I'd like you guys to get some additional practice by trying the try it questions, questions 1, 2, 3, 5, and 6 on pages 2 to 5 of book 1B. Thank you.